Okay, guys, welcome. So today we're going to talk about the product and quotient rules for logarithms. We've already talked about the power rule for logarithms, so this will basically conclude our three important properties here for logarithms. So what I hope to be able to do in this video is we'll talk about how to apply the product and quotient rules, and I've cut out some of the items in the textbook because I want to emphasize on how to expand and condense logarithms, which will be important for solving logarithmic equations. Okay. So first of all, when we have the logarithm of a product, what we're allowed to do, so if you have the logarithm of two numbers being multiplied together, x times y, we can break that into the addition of the two logarithms. Okay. So and of course, this works for any base, right? And a lot of times I will just write this rule with just the common log, but it will work for any base. Right? And it's, again, this is one of those things where it's not hard to prove, but sort of the idea behind it is that when you look at exponents, if you multiply two numbers with the same base together, you add their exponents. So you sort of have multiplication leading you to addition, right, in this sort of way here. And that's sort of a similar idea as to what's going on here, right? So we have multiplication sort of lending itself to addition. Okay, but let's go ahead and let's see this in action, all right? So we want to use the fact that we know that log of 6, and this is a common log of 6, is equal to 0.778. And of course, this is approximate. Now we want to use that information to evaluate log of 60,000, it looks like. Right? Well, of course, if we know what log of 6 is, then it's going to be helpful to break this into log of 6 times 10,000. And since we're taking a common log, it will be easy to find what 10,000 is. So by the product rule, we can say that this is log of 6 plus log of 10,000. Well, we know that log of 6 from the given information is approximately this 0.778. And for a common log of a power of 10, we're essentially just counting the number of zeros. So this whole thing here would become a 4, right? Because you can think of 10,000 as 10 to the 4th. So of course we get a 4 there. So of course that tells us that this is going to be a 4.778. All right, but the idea is that if you have a product of two numbers, we can break that into the addition of the two separate logarithms. Okay, so that's the product rule, and we'll do a little bit more with this in just a moment. Now, the quotient rule is sort of similar here, and the difference here is that you have division leading itself to subtraction, becoming subtraction. And you can actually show this using, if you can believe that the product rule is correct, if you think of this as log of x times y to the negative first by using your properties of exponents, then this is log of x plus log of y to the negative 1. And then you can use your power rule to bring that negative 1 out front. And then you exactly get the quotient rule there that way as well. All right, so that's what the quotient rule is. Okay, so with that in mind, we're going to suppose that log base 4 of x is 8.9 and log base 4 of y is 2.2. We're going to use that information to evaluate log base 4 of 4x over y. Okay, now first of all, if we have log base 4 of 4x over y, well, by the quotient rule, we can break this into log base 4 of the thing on top, the 4x, minus the log base 4 of y. All right, but we can actually take this a step further, because what can we do with this piece? Of course, we can break that up using the product rule. So this is a log base 4 of 4 plus log base 4 of x. And then, of course, the minus log base 4 of y that we had before. Well, now everything is in a way that we can find it, right? Log base 4 of 4 is 1, right? Because that's saying what power of 4 gives you 4. And of course, that would be a first power. Log base 4 of x was one of the given pieces of information. We were told that that's 8.9. And log base 4 of y is also given. We were told that that's 2.2. All right, so it looks like if we add all these together, these two will be a 9.9. And if I subtract 2.2, it should give me a 7.7. So we get a 7.7 there. All right, so that's the idea of the quotient rule. All right, now using the quotient rule, we'll see that this fact remains true, and this is something that comes up quite a bit. So it is useful, all right? And I want to sort of talk about why this is true. Now, if you look at the quotient rule, you can say that log of 1 over y, right, is log of 1 minus log of y. All right, but of course, what is log of 1, no matter what your base is, this is always 0. So this is always 0 minus log of y. So of course, that's just a negative log of y. Okay, so that's a useful fact that does come up. So just make yourself aware of that sort of equality there. Okay, now the reason why we talk about sort of these different rules for these logarithms is we want to be able to expand logarithms, and more importantly, we want to be able to condense logarithms. All right, so first we'll talk about expanding. So the idea of expanding logarithms is to use the power, product, and quotient rules to break a single logarithm into as many as possible, right? So you've eliminated any products, you've eliminated any fractions, you've eliminated any powers, as long as they're not being added or subtracted together, right? So for example, we can take this log of x over y to the 6, and we can try and expand this. Well, the first thing that jumps out is, of course, we have a division. We could say this is log of the thing on the top minus log of the term in the bottom. Right? Now, of course, log of x, we can't do anything further with, so we could just leave that as log of x. But in the second term, I can move this 6 out front, and this is a minus 6 log of y. All right, so that's fully expanded because I can't do anything else with y or with x. All right, so that's the first example. Now, in this one, we have log of the product AB squared. So now there's two things going on. There's the product of A and B, and there is the exponent of the 2. Now, since the 2 is being applied to both of them, that's what I'm going to worry about first. So we can say that this is a 2 by the power rule of log of A times B. All right. And then, of course, what can you do here? You have 2, and we need to be careful here because it's 2 times log of A plus log of B. Right? If you were to just say this is 2 log of A plus log of B without parentheses, then you're telling me that the 2 is, the power of 2 is only applied to the A, which of course is not true. And of course, another way that you can show this is apply your exponent rules on the inside, and this would be A squared B squared, right? But then if you separate this, this is log of A squared plus log of B squared. Then move your 2's out front. And then factor out the 2, and that's what this is. All right, so there's a couple different ways you can approach that one. Okay, now part C we have to be a little bit clever on, all right? Because we want to think about, well, what does it mean to have this cubed root here, right? Well, of course, that's a 1/3 power. So we want to think of this as log of x, y, z, everything under the root to the 1/3 power. So of course, now we can apply the power rule. The 1/3 can come out front. And now we have log of x, y, z. And now, of course, we can apply the power rule. And again, we need to be careful with our parentheses. So this is 1/3 log of x plus log of y plus log of z. Right? And they should all be in parentheses because the 1/3 of power applies to all three of them. Okay, now one last example of expanding, and that's if you have something like log of x, y, z squared. Okay, now in this case, the 2, this exponent of 2, is only being applied to the z. So we can't take that 2 out just yet. So since it's only being applied to the z, we can expand this with the product rule first. So this is log of x plus log of y plus log of z squared by the product rule. Right? And now, of course, the last thing to do, the only thing that's going to change in this step is the 2 is going to come out front of this other log. Right? And this, of course, makes sense at the end because the 2 only applies to the z, so I shouldn't see a 2 on the other terms. All right, so that's my final answer for this one. Okay, so now we can talk about condensing logarithms. All right, now generally condensing is a little bit easier, and it's also a little bit more important in general. Now we need condensing logarithms when we go on to solving logarithmic equations. So this will be something that we use again and again. And usually this is easier to do because there's usually sort of a set standard way of doing it. Usually first you're going to apply the power rule. So any numbers that are in front of a logarithm, remember we're going backwards now, any numbers in front of a logarithm would become the exponent. And then essentially any terms, any logarithms that are positive, you would combine them by multiplying their arguments in the numerator, and any negative logarithms, you would multiply their arguments in the denominator. All right, and when I say arguments, I just mean the thing inside the logarithm. Okay, so let's look at an example. So in part A, we have log of u minus 6 log of v. All right, now the first thing we want to do, like I said, is we want to apply the power rule if we can somewhere first. Now, of course, this 6 is out front, so I can make that the power of v. So this is log of v to the 6. All right, remember, we're going the other way now. We want to make this into one logarithm. Now, since the log of u is positive, u is going to go in the top, and the log of v to the 6 is negative, v to the 6 is going to go on the bottom. All right. Of course, another advantage of this method is that you know that you're done when you have a single logarithm, right? That's the idea, is when you condense a logarithm, you want to make it into just one logarithm. Okay, part B, let's do a similar strategy. So I want to take the 4 and make it the exponent of the x here. And the 20, I want to make the exponent of y. So now, of course, we can combine this into one logarithm, and this is log of x to the 4th over y to the 20th. Of course, we know we're done because we have one single logarithm. Okay, one last problem in this video. We made it a little bit more tricky, a little more interesting. So we have 2 parentheses log of x minus log of y, and minus log of z minus 3 log of w. Okay, now I think with something like this, our best bet is to distribute everything first, right? And then it'll be a little bit clearer to see what's going on. So if we distribute, this becomes a 2 log of x minus a 2 log of y. And now we want to distribute this negative here. So we have a minus log of z and a minus 3 log of w. Well, now we can apply our power rule. So this first term will become log of x squared. This next term will become minus log of y squared. There's no power on the z or coefficient for the z, so that's just going to stay log of z. And then 3 log of w will become log of w to the 3rd. All right, so now we're ready to put this in a single logarithm. The x squared is the only positive one, so that's going up top. And then the other three are negative, so we're just going to multiply them together in the bottom. So we have a y squared, z, and a w to the third. And again, we know we're done because we have a single logarithm there. All right, so that concludes this video on the product and quotient rule for logarithms. And also we talked about expanding and condensing. I hope you enjoyed, and I will see you next time.